Good morning, everyone. I'm Megan Matheson. I'm the co-lead of the Canadian Marine Shipping Risk Forum and also the Director of Strategy and Engagement with Clear Seas. I'd like everyone to note the session will be recorded and it will be posted on our website along with presentation slides after this session. And all registrants will be notified when the recording is available. Before we get started today, I'd like to take a moment to acknowledge that I am joining from the traditional ancestral lands of the Musqueam, Squamish, and Tsleil-Waututh nations and express my gratitude for their stewardship of these lands and waters since time immemorial. To introduce the Canadian Marine Shipping Risk Forum, it is a community of practice hosted by MEOPAR, the Marine Environmental Observation Prediction and Response Network, and Clear Seas. And we have been working together since 2019 for this community of practice. It is open to all who are interested in the work of understanding and mitigating shipping risk. So thank you so much for joining this session in our Beyond the Horizon webinar series focused on technology and its role mitigating shipping risks. If you missed any of the previous sessions, I'll put a link in the chat so you can go and find the recordings for all of the previous sessions in this series. I think we're on number 9 now, so there's getting to be quite a few. I would like to ask everyone to remain muted for the presentation, and we will have lots of time for questions at the end. So please either make a note of the question in the chat, you can submit it that way, or at the end, please raise your hand and you can unmute to ask your question directly. It's always great if we can get a bit of discussion going, and I'm sure I know there's lots of expertise on the call as well to talk about these things, the topic in more depth. And so without further ado, I will introduce our speaker. Today we have Anne Webster from Hatfield, and Anne has a background in physics and an interest in challenging problems, and she began her career in remote sensing back in 2005, developing change detection analytics using aerial and satellite images. Over the years, she's developed approaches to detect hard-to-see objects and classify land cover in scenes captured from optical, multispectral, hyperspectral, and thermal infrared sensors. She has led the research and development of several AI-based solutions, including classifying ships and detecting floating ocean plastic litter from spaceborne sensors. As part of her role at Hatfield Consultants, she managed the development of smartWhales space-based detection system, SBDS, which we will hear more about in a moment, a semi-automated tool to assist in tracking and monitoring North Atlantic right whales to support their conservation. So Anne, I will hand over to you. Thank you for joining us today.
Great. Thank you so much, Megan, for the introduction. Yeah, so I'd just like to start by acknowledging that I'm presenting from the unceded territories of the Halka speaking people, known colloquially as New Westminster, British Columbia. Yeah, and so today I will be presenting on work led by Hatfield, and just a little bit about us if you don't know about Hatfield. We're an owner-operated company focused on providing high-quality environmental and social science services. So we have a remote sensing and geomatics group and provides scientific and strategic support to a wide range of national and international organizations. Expertise in developing solutions based on data from optical and radar satellites, from airborne LiDAR, and data from drones. So we provide products and analyses to monitor ecosystem recovery, to assist in sustainable development on land and on the coast. So today, as mentioned, I'll be discussing our project that was part of the smartWhales initiative from the Canadian Space Agency. So the motivation for the project I'll discuss today is the plight of the North Atlantic right whale. You're no doubt aware of it. It's a critically endangered species. They have about 330 left in the world. They spend some of their time in Canadian waters. In recent years, these whales have changed where they go due to shifting climates and the impact on their food source. And so now we're seeing them present in the Gulf of St. Lawrence, and they traverse busy shipping lanes and active commercial fisheries zones. So that's where they really get impacted by either entanglement in fishing gear or by vessel strikes. So there have been significant efforts to help conserve and monitor these animals, including by the Government of Canada. They've set vessel speed reduction zones, and they trigger fishing closures when a whale is spotted. So current monitoring of the whales is performed by visual assessment in planes, on vessels, also with underwater microphones. In about the last decade, there have been several studies that show that whales in general can be seen in images that are taken from satellites, those satellites that have very high resolution images, so about 30 to 50 centimeters. And these satellites can actually be great resources because they can image offshore, remote locations more easily, without having to deploy personnel or equipment. And they can capture larger areas essentially instantaneously because they go over ahead at about 8 kilometers per second. So they can't see through clouds, and they can only see the whales, at the surface or just below the surface. And the image quality isn't as good as you might get from a camera on a drone. But the benefits certainly do complement the other monitoring technologies like the acoustic and aerial and vessel-based detections. So this is why the Canadian Space Agency launched their smartWhales initiative with support from Transport Canada and Fisheries and Oceans Canada. That's really to help develop space-based methods to assist in monitoring these endangered whales. So there are two streams. The first stream focused on the detection and monitoring from satellites, like I just discussed. The second stream focused on how other satellite information could assist in the prediction and modeling of whales, so based on factors like the location of their food. And actually, you may have seen the webinar earlier this year in this series from one of the consortiums in Stream 2 about the modeling and prediction. So Hatfield actually led one of 3 consortiums in Stream 1, and our partners were AltaML, Dr. Kimberly Davies and her lab at the University of New Brunswick, Dr. Sean Brilliant at the Canadian Wildlife Federation, and Dr. David Johnson and his group at Duke University. And the project just wrapped up earlier this year in February. So since it takes many hours or even days for a human to comb through a single 100 square kilometer satellite image to see if there are any whales, we really set out to develop a system to automatically process the satellite data to find whales, just to save the time and effort and allow for more rapid detections. So we developed a prototype cloud-based system to automatically locate the whales in the images. And we do this using state-of-the-art AI, specifically deep learning convolutional neural networks. And that tells them apart from, say, ice or boats or other objects on the ocean surface. At the start of the development of the system, there were no North Atlantic right whales that had been captured in satellite imagery. And as far as we knew, no whales in Canadian waters. So we broadened the scope of detection to different whale species. So we just detect whales generally, and make sure that when we perform the validation, we do a fair evaluation on images that had never been seen before, and that's where the focus on the North Atlantic right whale came in, was in the evaluation and how we do there. So I'll first walk you through the components of the space-based detection system, or SBDS, as I call it for short. And then I'll describe the performance we do have, and then move into discussing some of the challenges and next steps towards getting a more near real-time solution. So when you order and receive a very high resolution satellite image, the user just can place it in a designated cloud storage, and where that is, the system gets automatically triggered, scales itself up, and just starts the processing. And the first step is to take that larger image and chip it into more manageable chunks where the whales can be seen. So usually those chips would be about 150 to 200 meters long in length. The scene sizes will vary as they come in, but they're generally greater than 100 square kilometers. 100 square kilometers will result in about 4,000 chips, so there are a lot of chips going through. And then each chip, the brightness and contrast is adjusted so that the whales can be made more visible for the AI in the next stage for detection. So that next step actually involves 2 AI models. We have a first pre-screen step, and that first step just determines, is there even a possible object of interest here? Is there, the water, whale, ice, ship, some other floating object? And if there is a possible object, then that chip automatically goes to the next model, and that model will then confirm, is there an object present? It will draw the box around it, put the output, like say whale or what it might be, along with a confidence in that detection. And then all detections are logged in a database, including its geographic location. So we do keep that positioning information. So we do use this 2-step process. It allows for more rapid processing. Most of the chips that'll come through would just be uninteresting open water. that we don't care about, and the object detection can take a little bit longer. So by doing a faster pre-screen, that just allows us to process more rapidly. And actually, so once we worked through the development and saw how difficult it was to identify some of these whales in the scene, specifically the North Atlantic right whale, we did realize that many users would prefer a semi-automated approach, really keeping a human in the loop there. So you have a human at the end for final verification and really confirm the whale positions. And so we added an annotation tool that allows for an expert human, like a marine mammal observer, to go through all the chips where the system detected a possible whale and then verify that. And then the verified whales get tagged back in the database for reference. We also have a web map interface, so that allows the user to search for all the system detections or just the verified detections. You can also filter by geographic location, by date. It lists the detection coordinates. It shows the image chip that will be corresponding to that detection if you select one. This one here is an example of Cape Cod Bay in early April 2023. And this next example here is the Gulf of St. Lawrence, 2023 also. It shows the single verified whale in the Jacques Cartier Pass up there. So the model confidence and the coordinates are just provided in the pop-up pin. You click on that. And then the chip is shown there, the whale in the imagery. So this is just our first prototype map here. So it can be updated in the future to display other information that you might be interested in or users might be interested in, such as the date the image was captured, which satellite captured it, or say which image footprint was covered. So just to get a sense of where possible detections could have been. So all information that could be very useful in seeing where we actually looked and where we didn't find whales. So this information is all available in the database and can easily be retrieved and added to the web map. So now on to validating. So to validate the performance of the system, we need to use data that wasn't used for development and training the system. And in the context of the smartWhales initiative, because detection of the North Atlantic right whale was the focus, we tasked satellites to capture images in the habitat of the North Atlantic right whale, specifically Cape Cod Bay in the spring and Gulf of St. Lawrence in the summer of 2023, where they're known to be. And of course, because we were ordering these images new and there was no guarantee we would actually have whales in that imagery, when we wanted to make sure that we had something to evaluate, we also went back and looked at some archive data that we hadn't used in development and selected a scene from South Africa that was known to have an aggregation of southern right whales. So with that, we had a total of 18 scenes, covered about 2,000 square kilometers. So each scene is about 100 square kilometers, and just you can see here are the footprints. So on the top is the Cape Cod Bay. You can see that one scene there covers quite a bit of the area. It's a relatively small and sheltered area of Cape Cod Bay compared to that same area down below in the Gulf of St. Lawrence, where we tasked in Chaudiac Valley and up near Anticosti Island there in the Jacques Cartier Pass. So we ran all of the data through the SPDS at once, just a big sort of test to see that we could process it efficiently and how well we could process all that data. And then we selected a subset for expert human annotators to go through that manually. And then we'd be able to compare the SPDS whale detections to that of the human. So what did the humans find? So we had 3 people. They went through nearly 31,000 chips over the course of a few weeks, and then went through and labeled either a definite whale or a possible whale. Definite was when you could see a body part of the whale visible, something like the fluke or the rostrum. And it was labeled possible when it wasn't really as clear, but there was an object that was consistent with a whale part, perhaps, or a splash pattern that was consistent with seeing a whale. And so then we had a quality control process that assessed the consistency of these whale designations, and that resulted in 78 definite whales and 45 possible ones. So the definite ones were mostly in Cape Cod Bay, just likely because of the surface behavior there. They tend to be active on the surface quite a bit there, and the calmer waters. And of course, there were many in the South African scene, which we knew when we had ordered as well, and less in the Gulf of St. Lawrence. And so when we're evaluating, we considered the Canadian US waters of the North Atlantic right whale habitat separately from the South African scene because the conditions were different. So you can see the image on the top left there. The waters off of South Africa are quite clear and green. And so a black whale shows up really much more obviously there than in, say, the next one over in Cape Cod Bay. So that's why we want to really consider them a little bit separately there. So what we do consider as a metric known as recall, and that's related to how many whales the SPDS missed or misclassified that the humans labeled as whale. So if we consider both the definite and positive whales, we see that the system here is pretty robust. It misses about 25% of the whales in both cases. Example of a missed whale is in the top right corner there. Those examples of two that the system missed. And we also consider a metric called precision. That's a measure of how many whales that were detected by the SPDS that were actually labeled as whales by humans. So related to the number of false detections where there would be a whale, but the human would say, no, it's something else. So here, the environment really makes a big difference. In the South African waters, 5%, only 5% of the SPDS whales were false detections. But in the Canadian and US waters, about 80% of the detections were not whales. These were usually glint or waves mimicking whale features, such as the callosity pattern on the rostrum is a white line, and so some of the water tends to look like that. So it really just highlights how much more difficult the detection task is in these waters. It's harder for humans as well as the AI. An example of the false alarms is shown in the middle there. But I want to say, even with this seemingly high false alarm rate, so the total number of chips that the SPDS thought there might be a whale in turned out to be less than 2% of the total chips. So if a human validator only had to sort through system detections and confirm detections, they would have gone through 479 chips out of the nearly 31,000. So that really represents a 98% reduction in the number of images that you would have to look at. And that would have resulted in finding 75% of the whales that the humans found. So this is really encouraging given how challenging it is. And what I've done here just is on the right, so you can see the whales in satellite imagery. You've just kind of been seeing these blobs just to give you a bit more sense of what we're looking at. Next to these, there are drone images of, it's not the same whale at all at the same time, but it's one that's in a similar position to just show you what you're seeing in some of these less glamorous satellite images of whales, kind of seeing the wake pattern from the feeding or a slightly underwater, whale in motion. So these are the kinds of things we're seeing in the satellite imagery. So we succeeded in developing a prototype system. It's scalable. It has parallel processing, so it's running detection on some chips and still pre-processing others. It's detecting on many chips at the same time. And just without any other optimizations, which could be done, we're really currently at the point where we're processing 100 square kilometers in about 10 to 20 minutes with the system ramp up. And it's not linear with adding more. We process the entire set within a matter of hours. And that it really also depends on how many images how many images have objects in the scene there. And this would take a human, days to go through. So there's room for improvement, and but even though the current system really still can be used to support current monitoring and gaining more insights. So especially in areas of known aggregations or in rarely or irregularly surveyed areas. If it's hard to get to, why not have a satellite have a look and see if we can find these whales? Let's talk about sort of towards more near real-time automatic detection. So in terms of reducing shipping strike risk, the ideal solution would be to have constant satellite data, near instant detections, so locations are transmitted to the ships and collisions avoided, right? Unfortunately, there are challenges in data collection and latency and system accuracy. I'll talk about these. It just kind of prevents this ideal solution, but we can certainly work towards a better system that can still help out. So I'll also talk about where we can go from here. So this first challenge around data collection, there are a few important limitations to consider about very high resolution satellite imaging. So the table you see here lists the current options of satellites we have, along with some of the anticipated ones in italics. The bolded options are the ones that we used in our validation. The first thing to note is that, unlike in the movies, you can't get an image any time of day anywhere. Satellites like this typically capture once a day over your area, and most capture an image at the same time every day. You see usually about 10:30, sometimes 1:30 local time. That is starting to shift, though. Just this year, a set of Legion satellites were launched this summer, 4 of them, and 2 of those actually will offer a various time of day. So it changes every day what time of day they'll go by. So we are changing the time of day. It's moving forward in the industry. But on top of time of day, the size of the image can also be a bit of a challenge. It can cover wide areas, but because the satellite typically moves in a north-south direction, as shown in the little graphic there, you get a long strip that way, but in the east-west, it's only about 10 to 20 kilometers in that direction. And some satellites can do little acrobatics, and they can get more like 60 kilometers, but it's not an enormous east-west extent. So there's that limitation as well. And they aren't necessarily available every day. It depends on what other orders they have on orbit, and of course weather, clouds, cloud conditions, and environmental conditions. So the way tasking works now is you give notice that you'd like to buy an image over a certain area. I usually give 24 hours notice or more, and then you might get it on that day you requested, or you might not, depending on various factors. So in our experience, we would get images usually on the day we asked for it, but within about 3 days. But sometimes it took up to a week or two, even when the weather was really bad. So that can get in the way. Some operators do allow you to pay more for priority tasking and more guaranteed acquisition, and that can help out, but it just costs more money. And then once the other issue is with, once the image is acquired, we don't get it instantly. So it does have to be downloaded from the satellite, and then the satellite providers, they process that data and then they deliver it. And that takes about 2 or 3 hours. So it's not quite fast enough for near real time. We get that. We can run it through our system relatively quickly, but we're talking about receiving and processing all within a few hours. And the last big hurdle to mention is cost. So, these satellites are very high quality images, provide very high quality images, and, they are expensive satellites, and then the data can be expensive also. Although, there's certainly room for negotiations for large data purchases with these providers. So challenges, I've mentioned already the appearance, optically dark waters. Dark whales are hard to see in dark water, right? And so more often than not, the whales we're interested in aren't these beautifully obvious still whales just waiting at the surface, like the ones there on the top left. They're in motion, they're submerged, they're harder to make out, especially if we want to make out the species. So here, also at the bottom, I'm showing you some examples of possible whales. So the splash pattern being consistent, but no obvious whale. Or in the case of the far right, you might see a few 2 linear features there, little white features that kind of looks like the white stripes of the callosities on the North Atlantic right whale if it was under the surface, but there's just no other indication to confirm that it's a whale. So because it's harder, we did include these possible whales in the system training so that it would find them and return them, and that the human can decide in verification. But then that means that we get more false detections that way. And the AI models do need a lot of data. They need a lot of examples of what whales look like in lots of different conditions and positions, ideally thousands of examples, and ideally you would have thousands of examples for each species. Right now, we're currently at 500 whales total of all the species that we happen to have. So it's hard to get a lot of samples, especially of different species, and in waters that we're interested in where they don't have typically large whale aggregations that you can capture at once. And then another challenge would be the water. So, assuming there are no clouds, there are some wave conditions and sun reflections that can make detections difficult. So, we can see extremely calm and still waters, good there seen on the left, and moderate to average has a bit of sun glint, very light waves. Poor through very poor, you get increasing wave patterns and sun reflections and whitecaps. So we have definitely seen whales in the good to average conditions. We aren't really sure what they look like in the sub-average to very poor. We just haven't seen examples in that yet. And We task the data in Shediac Valley, the Gulf of St. Lawrence. That tends to be the average, all the way through actually to very poor imaging, and the sheltered Cape Cod Bay is more where we get the good to average. So it's also why we could see the whales more easily in the Cape Cod Bay imagery. Okay, so I've presented all these challenges. There's several of them, but what can we do about them? Where do we go from here? So with the appearance issue, we just need more examples of known whales and what they look like to help boost the performance and eventually get to species level detections. It's hard and time consuming to collect, thousands of examples. So we really want to be able to leverage the aerial and drone data that researchers and organizations already have and have collected and use those to train the model. But because these images, they don't look like the satellite ones, right? Which means they don't really help, unfortunately, as is. You need to transform them to look more like satellite data. So that means color shifts, making it not quite as sharp, making the whales not as obvious, because when they get them drones and for research, obviously it's these nice high quality images and it's not what they look like in the satellites. But to do the transformation, it's not a single thing to apply because there's different conditions on the input. What you'd have to do for each image is slightly different. So to overcome this challenge, we're working with our colleagues at AltaML to develop a generative AI solution that would automatically transform these to look like satellite images. And that way we could get more samples to improve the performance of the SPDS models. And we also want to get examples from other geographic locations. So you can see on this map here where our data is from currently. And we'd really like to try the system actually with images on the Canadian Pacific side, for example. And then with the water variations I discussed, we just need a better understanding of the detection limits. So far, we think the wind needs to be about 10 knots or less to see a whale. But just more understanding of what the whales look like at these different surface conditions would really help with this. Generally, just a better understanding of all the impacts, and including whale behavior, would really help. And some R&D's already underway. Our colleagues at the University of New Brunswick are exploring some aspects of this right now. And then lastly, in terms of data collection, for that, it's really a matter of new technologies and advances within the satellite industry. But we see that things are already moving in the right direction. It's going towards higher resolution, more often, different times of day, lower latencies, faster processing. So it's all going the right way. And even in a few years, there will be much more to work with. So how could we apply this to help reduce ship collisions in the nearer term? So, once the SPDS system's been improved with more whale examples, and we have a, say, tasking and delivery arrangement made, you can imagine a scenario like this where we combine predictive modeling of things like conditions for food abundance and a previous risk map that's based on last seen locations, whale traveling models, and all that. And use that information to decide where to task imagery. This could be based on, say, even where it's harder to reach with aerial surveys, or just based on specific risk areas to be explored that's more pressing to explore. And so then can task the images in those locations. They get delivered and automatically processed by the SPDS. Right now, we can do that same day. Maybe we can get to twice a day in the near term. And you combine that with other daily sightings and detections from other sources and input that to update the risk models and then communicate those out. So, this isn't a perfect solution, and satellite monitoring methods aren't a perfect solution on their own, certainly. None of the tools really are a standalone, single, magic bullet solution. They're all tools in the toolbox, and that really is what the satellite detections do offer, another tool. It's complementary technology, and we really think that it is an important one and can contribute to whale conservation. I'd just like to finish by acknowledging the consortium team members here that made the SPDS possible and provided very valuable whale-related advice and expertise. And of course, a big thank you to the Canadian Space Agency, Fisheries and Oceans Canada, and Transport Canada for the smartWhales initiative and for funding this project. And if you are interested in, or know someone who might be interested in testing the SPDS, including the Pacific, where we're really interested in trying out the system, please be in touch. So here is, I'll just leave our contact info for you. be happy to hear from you. And also, thanks for your attention, and happy to take any questions and conversations you might have.
Thanks so much, Anne. That's really interesting. And yeah, good to go through some of the challenges that you've been experiencing and some of the ways forward. It's fascinating to think about the possibilities and then also the reality of kind of where we are and where we hope we can get to. You mentioned you're interested in trying to test it out on other whale populations or other areas. What other whale species do you think that this could be applied to? Who do you think would show up well? We've
Yeah.
already seen the North
So
Atlantic right whales are a bit challenging.
they are, yes, a lot of yes. There is evidence. We haven't included humpbacks yet. So right now we have the southern right whales, the fin whales, um, which do come sometimes. I know there are. I'm not sure about the minke, how well they'd be seen, but we haven't actually looked at humpbacks, and I know there are some satellite imagery of humpback. Uh, they probably likely come up with their features, especially their large fins. Um, what we'd like to detect, but it's probably very challenging, so not quite answering question is, unfortunately, I think orcas, the population in the Pacific here, they're small and black, but we would like to, eventually get towards that detection as well. That's one of the populations that would be great to be able to use this technology on. It's just part of why we want to test out here in the Pacific and see what we can see.
Do you think whale speed would influence how well the images show up? Because the North Atlantic right whales tend to be very slow, whereas orcas tend to move a fair bit faster. Do you think that
It's
light would be able
Yeah,
to capture them?
yeah. It's more about how much time they spend at the
At the
surface,
surface.
which
Right.
is, I guess, related to the speed, right? So, yeah, absolutely. So, like I mentioned, the satellite imagery is essentially instantaneous, so it's a snapshot. So
Mhm.
you get what you get in time. And I have seen shots of you can see sort of a whale surfacing, and then all the whale watching boats around it at the same time. So you can just get that instant shot. So yes, I think it's more about surfacing and pod behavior. So something like the orcas, they might move faster, but there's more of them, and they might surface at different times. So yeah, it will likely depend.
Yeah, that's really interesting. So at the very beginning, you talked about some of the other whale monitoring tools that are currently in use, specifically for the right whales and the Gulf of the St. Lawrence. How is this system, or could this system work with those other tools to augment? Because we've heard about there's some thermal cameras that are looking for whales, and then they send those images to a person to look at and verify before they say to the ship or say to Transport Canada, yes, there's a whale present. Do you think that this sort of imagery could feed into some of those existing systems, depending on how quickly you can get it?
Yeah, I mean that's the hope. I think so. The idea again would be right now we could probably do within so similar to some of the aerial surveys that are done. They go out to fly for the day and then provide that data. It's actually for the North Atlantic right whales and other whales is on a Canadian platform known as Whale Insights as well. So that's one of the things where one of the types of systems that could input um, SPDS detections that have been human verified. We have built the system with an API so that other users could actually tap into, authorized users could tap into that database and get that information. In terms of mixing with other detections, it does require a collaboration effort. In my scenario here that I've kind of put in the previous slide, go back there. That really is where we can include the other detections. I think all provide different information, and
Mhm.
I think it really is the more information you have about the landscape at a certain time, the better it is. So that includes the thermal detections and the acoustics. I know that the acoustics and vessel-based detections can be more quickly communicated to the uh, to the community, but there might be a way to aggregate it all together in this way where we do update sort of situational awareness information.
Mhm. Yeah, and I think looking at this cycle here, where you look at the predictive model, which was the other stream of the Smart Whale initiative,
Yeah.
where are the whales likely to be based on all kinds of factors that seem to influence their feeding and travel patterns. and then you're trying to take pictures to see, are there actually whales there? Have you got to the point where you've been using these two streams together to come up with a collision risk map?
Not yet. We'd really hoped to. We just couldn't quite get there at the end of the project because both streams were kind of coming to their conclusions of getting those things. So it would definitely be a next step work. But now that the stream 1 and stream 2 do have their output products, it's the time where we could put them together. Yeah, it just hasn't happened yet.
Is there a timeline for that, or is it intention? Like, is there another phase where the two streams will be run together, or?
Not within the current, the current initiative as is completed. So it really is a matter of being able to find another funding source and then really collaborate in that way.
Yeah,
So we hope so. We hope something will come up. Yeah.
fingers crossed for sure. And then would the intention be to share that collision risk map with government and with the shipping industry to try and highlight, where they need to be more alert?
Yes, that's the hope. Of course, there is work with that industry to be done, and the same with the fisheries as well. Knowing, it for we have to have an understanding of limitation of being able to say exactly, is it what kind of whale does it, with the ship collision, we don't want to hit any whale. With fishing, it matters more like sort of the type of, is it really a North Atlantic right whale? So just having just sort of abstracting just so that it becomes really clear what for the industry, what they need to know and when and how the information best benefits them is definitely work to be done. And then I think absolutely that information could be shared and presented in the most useful way to the industry based on the strengths and limitations. And again, combining all of these things together really helps for a more comprehensive solution.
All right, we have a question in the chat from Elijah. Can the detection system be taught with the imagery of whales that are more common, but with similar shapes, at least from a satellite perspective, and then a human can verify and supervise some of the learning? So is there a way to get more images into your learning system?
Yeah, so it is really hard to get any whales images from space. We do have, so there's 500 whales we have captured are from archive imagery, different whales, gray whales. Gray whales were pretty easy to see, a few fin whales. The challenge really is in again that because the whole point of the system is to take less time, but it does take a lot of time to comb through a lot of imagery that doesn't have whales in it to find them, and that's really why we think moving forward the best way to get a lot of examples is to use this aerial and drone imagery and really transfer that to look like the satellite data. Any data like that can be used to help train, and it does help. The general whale shape does help detect, but it will often do so with less confidence, or sometimes just say it's an other unknown object. So it really is it is useful, and that's why we have used the other whales from around the world. It helps even if it's not exactly the same. Still need a lot more if we can. So again, let's leverage as much of this data sources as we can to move this forward.
Yeah, that is a really clever idea to try and take other images that we have and make them look like satellite images. Do you feel like that's successful? Like we're able to transform the images in a way that the system would recognize them as satellite images?
We aren't there yet. It's definitely an ongoing research question we've started to look into. It's a techniques of generative AI, so either also known as style transfer, and the technology is quite well known in other applications. It just hasn't been applied to this one, and so there's definitely work to be done in the aquatic environment to get the representative samples there. But yeah, we do think it's possible.
Right. Yeah, everybody else in the audience, if you have a question for Anne about this project or ideas or things that that you're working on that might be relevant or related, you can feel free to put your question in the chat or raise your hand and unmute to ask a question directly. Either of those options are encouraged. Yeah, I was trying to think other things that this might be useful for. So at the moment you're working on trying to get more imagery into teach the AI system how to look for whales. Is there an ongoing process where you're continuing to get more satellite imagery? I guess what frequency do you do that?
Yeah, so again, to get more samples, you want to, the process we went through was to look for areas where there were known detections from the other methods, and acquire it near the same time. So we were looking at the acoustic coming in the aerial, and then seeing, where were whales seen yesterday? Where can we try to find them today? Those kind of tasks can happen. Because it's commercial data, and there is, you do have to pay for the data sources, that it's not really an ongoing, continuing every year effort. At the moment, it's when, as funding is available to add to it. There are also other data sources and other collaborators. I know that the sources within NOAA and the um, other academic sources actually have satellite data and are continuing this work as well. And so more data becomes available through other sources, and as those get published and available, and there's really a whole community of whale detections occurring globally, actually. And so it's a whole effort to continue to get more examples, and that will help us as well with the SPDS and other technologies and in advancing other research, in advancing, the technology for limitations and seeing it in different waters and all that kind of stuff. So it's ongoing, actually all over the world, but it is really often dependent on the imagery and funding available.
Are you using aerial images from the NAS plane over flights as well? The National Aerial Surveillance planes? Because I know they do generally have a plane tasked to fly over that area.
Are they? I mean, so I'm not familiar with that too.
Oh, so
This is
Transport
the one from
Canada
Transport Canada. Yes, it's Transport
has a
Canada. Yes, yes,
red
yes. So
plane.
that's some of the imagery, yes, that we have access to. Also, the North Atlantic Right Whale Consortium also has a lot of aerial imagery. So that's some of the aerial imagery that we would like to make use of for training the models
Mhm.
within the SPDS. Yeah, absolutely. It's just another one of those needing to transform it to look like satellite data.
Yeah, and it takes
Yeah,
time to make that
absolutely.
happen.
Yeah. Yeah, and even now, so I mean, one of the use cases for now is if there is an area that's known, to have whales, and we want to see a smaller area on a more regular basis, it is something where right now the system could work towards that kind of more automated, maybe more in a fishing context, or something, where an area, or actually some of the research about where these whales go at other times of year. There are areas that they suspect they go, but no, it's just too hard to get there. So a lot of the satellite technologies could help in that, because these really remote areas where people can't go easily, these are places that we could get imagery from very easily from the satellites.
Yeah, and I think that'd be a really fascinating area of research, because there is a lot that's not known about many of these whale species when we don't see them near shore. Where are they? Where did they go? What are they doing? And what does that tell us about their behaviors and their needs? Um, Sam's got a question. Sam Mansfield from Transport Canada. Are there examples in other countries or areas where collision risk maps are being developed in near real time that might help this work? Is anybody else doing this?
Um, Not from satellite data that I know of. The satellite detections, and some other groups are looking at, again, sort of the AI technology in improving the detections from um, from satellite image, from very high resolution satellite imagery. Um, as far as I know, it's still, a lot of them are still very much at a research level, and none have gone to the point of a full system that is near operational from satellite imagery. But again, the community does meet to discuss these challenges, and how to help each other out. And so we all kind of are moving forward in terms of the detection piece. The collision risk map, a lot of I can't quite speak to the other stream that really worked with the predictive modeling and the level of that that advancement in other areas. I'm sorry about that part. It's not part of my expertise there, but certainly in
Mhm.
satellite detections, it is being explored. by other groups, but not at the level of a near operational system.
Yeah, it's an interesting thing because there's certainly other risk areas around the world where whales are at risk of collision from ships. So can this be applied elsewhere once it's fully functional?
Yeah, and the same limitations will apply a lot of places around the world, but yeah, I think it can help.
We've got a question from Orla Robinson from the ECHO program. Are some of the other global researchers who are gathering satellite images building or using their own whale detection models, or are you working together or planning to work together on strengthening this SBDS model?
So can you just repeat the beginning part of that?
Yeah, so other people out there who are gathering or
Yeah.
using satellite images to detect whales, are you all using the same whale detection model, or is
Mm.
everybody kind of creating their own models to try and identify whales from satellite images?
Yeah, because at the time this was developed, this work started, there were no known detection models using AI for this. So there have been a few parallel efforts. We tend to converge on um, similar similar. No, I wouldn't say exactly the same architecture or the same exactly training strategy or approach. There have been a few papers released about this as well, and certainly there's the group. Um, the International Whaling Commission actually has a group that needs to discuss how to label these and as a community and be more consistent about moving forward with this technology. So I'd say that it's still emerging, and the community is still working towards the ideal solution, and it will depend a little bit on the locations, because they highlighted, because we didn't have any in Canadian waters when we started using locations from around the world, it didn't work just out of the box as is. So really getting either a local solution or a global solution, you'd have slightly different approaches to your modeling. But yeah, it's definitely more work is being done, but it's still quite new.
Mm. Really exciting. Last call for any other questions. Anybody have anything they'd like to ask Anne about this work with satellite imagery and whale detection and trying to save the North Atlantic right whales in the Gulf? Anything else you'd like to share anywhere? I guess you've mentioned that the model still needs some training, and other areas could be fun to try out if there's interest.
Yeah, absolutely. Encourage again. I'll put
Next steps.
my emails up again there. Please just feel free to send a note for if you don't have any other questions or have an interest in knowing more. With us.
Okay. Well, I'm not seeing any other questions at the moment, so I think we'll wrap it up there today. Thank you so much, Anne. It's been really interesting to learn more about this project, and I really hope that we see that collision risk map coming out, that these two different streams can be combined as they were intended, and yeah, we'll be able to avoid the whales more effectively. Just a reminder that the presentation will be posted and everybody will be notified when it's available. And stay tuned. You can sign up for our mailing list on our CMSRF webpage if you'd like to be notified for future webinars as they come up. And if you have an idea, if you have some technology you're working on you'd like to share to reduce shipping risk, please do let me know. We're always looking for more information to share and spread widely so that collaborations are possible and new ideas are sparked. All right. Thanks, everyone. Have a great day. Take care. Thank you, Anne.